Mentally Math!
Let's get mental!
All right.
Are we recording?
We are. Yes.
Oh my god.
Hello world. Was that screen on?
No, I believe those are pretty much cries of PE joy out there.
I wouldn't know where it was.
Okay, anyway, focus please. Okay. So I will assume that people have gotten a few of these done.
I was setting up my paper now.
Okay, I'll take one deep breath and let you get out at least a couple of. I don't do these very quickly, so you can get one or two done. I'm sure I will not outrun you. Okay. So this time we're multiplying it 3 times with a negative sign, so that is an odd number. Yeah. In case you didn't notice, so it'll be a negative, and then so 5 times 5 times 5 is 125. Yeah, it's terrible 5. Okay. And then yes. Is this going to be totally on topic and not a waste of time at all?
It's about 8, but it's never.
Okay. Then, so 8 times 5 is 40. But we're doing scientific. They make a special point to tell us scientific notation on this because I actually would be able to get the exact answer if you felt like it. So times 10, and so those 2 would come to negative 2, those 2 values combined, but we divided this by 10. So it's actually to the power of negative 1, which is 1/10, which is basically makes this 4/10 in scientific notation. Then, oh, that's just double. No worries. This 1 8/10. And then this one. You got to be a little careful about the wording of it, but really, it's talking about 2 square. Well, that's not square. 2 squares. Okay. And so each square is going to be 3 feet by 3 feet, which makes each one of these 9, which makes it 18 square feet. Alright, then this is just asking what is 2/3 of $45 is $30. Then this is asking what's 1/3 less of $45 is $30. Yep. And then, okay, I'm going to assume everyone can answer this question, so we'll all answer it together. When plotting an ordered pair on a coordinate grid, which axis do you start with? Ready? 1, 2, 3. The x-axis. Yeah. Well, I kind of made this a little bit.
No.
I kind of made this a little too obvious this morning. I kind of threw out a hint. Which axis do you start with? And everyone was like, ugh. So. All right, then. Did you realize you're supposed to estimate?
I'm not even gonna say what I was gonna say. It happens every single time. I literally got $2.
I will take that as a no. Yes. So we're just working with $40. So 1/10 of that is $4, plus another half of that added to it is $6. All right. Okay. So, all right, class. So, yesterday's video took almost an hour to record.
Wait, what?
Yesterday's lesson was like almost an hour. Today is a little bit the opposite of that. You're going to be kind of like, oh, thank you, Captain Obvious, on this one. So, I didn't come up with it. All right, so this is solving literal equations and transforming. It sounds a lot trickier than it is. And it's kind of weird that these are literal equations because they seem kind of figurative to me. You know. So the idea with this is solving for x is really just you want x on one side and everything else on the other side of the equal sign. So you don't need to really solve anything here, you just rearrange them. So if I want to get the a off of this side and put it over on this side, what should I do?
Okay, subtract A on both sides.
Subtract a from both sides. A minus a. I'll call on you for the next one. And then a, and then so this goes blip blip. It's gone, and so you end up with b minus a. That is example 1. Yep, that's all there is to it, kids. It gets well. I don't know whether you want to think this is better or worse, but it gets more like this. Okay, so this time, if we want to, I'm doing air quotes, solve for x, and get to x equals and everything else, what should I do to both sides?
I divide A.
Yes, so this time I divide this by a, and I divide this by a, so this goes blap, blap, and it's gone. And so then that gets me, da-da, and that's example 2.
That's technically mental math. That's easier.
Yes. Okay, now this does have what I think is sort of a useful bit to it. Yeah.
I was going to say, is it still wrong to call this the E word?
Using the this is pretty easy, right? Okay. Yeah. Well, we can use the E word, I think, this one time. All right. Now, so this is where this could be kind of useful. So this is an equation, right? And you're trying to come up with an equation where, say, so area equals length times width. So say you've got a rectangle, and you know that the area is 8 skunits, and you know that the length is 2 units, and then you don't know what W is. Like, this is kind of, you could come up with a kind of a handy equation. It's like, oh, what could be a formula for that. So what we want to do in this case is come up with an equation of W equals, and then everything else thrown in there. So in order to do that, what should I do to both sides of the equal sign? And then I'm basically going to flip them. Yeah. Yes. That's an L.
So
Length times width. So A divided by L?
A over L.
Is that it?
Yeah.
Are you sure? The other
W equals
the other side. Now, if I do this, I have changed the meaning of the equation. So I need to do one more thing. When you're dealing with an algebraic equation and you want for it to stay equal, you do the yes.
The same thing
Huh?
to the other side?
Yes. So both sides are divided by L. It's all right. It's all right. And then this ends up being black. And then I'm gonna switch them so that W's on this side, and so then we end up with W equals I have to change the code. Equals A divided by L, I know it's silly looking, kind of weird. That's even worse. Here, there. Okay, L. That's even worse somehow. Okay, anyway, and you know, say in our little scenario here, then you could go, oh, okay, so the area divided by 2 get me. Oh, so that's 4 units. Oh, nope, that's great. Oh, so that's 4 units. Oh, so handy. Okay. Now this next one. Let's see. Yeah. Oh, yeah. So, this is this is a very unsatisfying example. I have to warn you. Okay. So you're gonna just be like, really? We're finished? Okay. So the concept here involves something called your principal square root. It's just a term. It's just a term. So now, say you've got so we know 5 times 5 equals 25, right? Yeah, and we know that -5 times -5 equals 25, right?
Yes.
Okay. Oh, you can put these in parentheses. Okay, so if you said, what's the square root of 25? Is the answer really -5 or 5? Because it could be either one, right? So to kind of answer that, you can say that the principal, what we would usually do for a square root is give the principal square root, right? And that would just be 5, is what we think of the principal. And then if we wanted to specify that we are dealing with negative numbers, we could say like that, right? And so then that would be an indication that the answer would be the -5, right? Because it's -5i.
Never mind.
Okay, so that's pretty simple to get, right? Other than this, you're normally just going for the principal square root, but sometimes they do want to specify that you are going to have a negative. You're dealing with a negative, so they put this out here, which is kind of like saying, take whatever answer you get here and times it by -1.
Times it.
Multiply it, excuse me. Okay. So the 2 square roots, now this is a little bit deceptive because it sounds like you're actually trying to get what the real square root of 5 is, which probably has some long string of decimals associated with it. It's not. Is just to say, the 2 square roots of 5 can be stated as the regular principal or the negative. That's the answer to example 4.
What?
Moving along. I know, it's very unsatisfying. Okay, now we are introducing a symbol. It's if I could write. Okay, so it's like square root, except it's cube root. Where, say you had that, what it's asking is, instead of what times what is 64, it's saying what times what times what equals 64. Which is, anyone who wanted to tell me who has not answered a question yet today? I don't think you really have, yeah.
4?
Yeah, so 4 times 4 is 16, 16 times 4 is 64, therefore the cube root of this would be 4. Cube root, I know, right? It sounds like you pull a carrot out of the ground and it's like a cube carrot. Anyway, okay. Oh, thank you. All right, so I don't think these will be too hard for you to figure out. So what times what is 1,000? I think everyone could just say it. Ready? 1, 2, 3. It's 10. And what times what would be negative 27? It would be
negative 3.
And that is lesson 106.
Are we going